Hello and welcome to the first in a short series of videos about diodes. Diodes are very useful components in electronics. They have the characteristic property that current can flow through them very easily in one direction, but not in the other direction. They have a very wide range of applications in a whole load of different circuits. Most of the diodes that we'll be using are based on the PN junction that we've seen before. And I'll quickly revise the key features of that type of diode before we start looking at the applications. This will also allow us to introduce the concept of an ideal diode and Shockley's equation. Shockley's equation is a bit like Ohm's law for diodes. It gives the relationship between the voltage across the diode and the current flowing through it. However, it's a non-linear equation. So circuit analysis using Shockley's equation is much more difficult than just using linear components like resistors. But we'll look at some techniques that you can use to analyze circuits containing diodes. We'll also look at the phenomena of breakdown voltage. An ideal diode, if you're trying to push current through it in, if you like, the wrong direction, does not allow any current to flow. However, all real diodes have a breakdown voltage. It's related to the fact that if the electric field across the diode gets above a certain critical strength, then the diode breaks down and current does start to flow in this reverse direction. Zener Diodes are components at which that breakdown is very well controlled, and they often have comparatively small breakdown voltages. They're used a lot in voltage regulator circuits. Finally, we'll be looking at some typical types of diode, and the one that we'll most commonly use in the lab is the 1N4148, a small silicon diode. We'll start, however, with the circuit symbol. Now, the circuit symbol for a diode looks like this. You can think of it like an arrow attached to the wire, with the wire carrying straight on through the arrow into the rest of the circuit. And then there's a bar across the arrow like this. And that is a diode. This side of the diode is called the anode, and in a PN junction, this would be a P-type material. This side of the diode is called the cathode, and in a PN junction, that would be N-type material. Now, if the voltage at the anode is greater than the voltage at the cathode, so the voltage here is greater than the voltage here, then we would say that this diode is forward biased. And current can quite easily flow from the anode to the cathode in the direction of the arrow. However, if V1 was less than V2, then we would say this diode is reverse biased. Current is trying to flow from the cathode to the anode, and in an ideal diode, no current could flow in the reverse direction. For real diodes, however, as is noted on the slide, there is a very small reverse current that would flow in this, if you like, wrong direction. It's a small amount of current known as the saturation current. And in the next video, we'll have a look and see where that saturation current comes from. Since diodes only allow current to pass in one direction but not the other, it's extremely important when you're building circuits with diodes that you put the diodes into the circuit the right way round. There's a convention that there is a black band across the body of a real diode where the cathode is. That black band there represents this black bar here on the circuit symbol. Okay, that's all I need to say for this first short introduction. In the next video, we'll have a look at the PN junction and see where these properties of the diodes come from.